Yeah, we can continue. So,
Okay, we should wait a minute for people to reconnect. Someone is talking in the background. And shall I continue now? Can you mute everyone except for me? All right, so briefly, again in the news recently were these burnt papyri. So there's some burnt papyri from, this is right next to Aswan, Sian, on the coast of the Nile. And these were burnt. And so Brent Seals and his team were able to look at this little burnt scroll from En Gedi and read inside what it says, but this is because they had metallic ink that made it easy for X-ray or CT machine to read what's inside. But now there's this challenge to read non-metallic ink, and they were quite successful in reading these burnt papyri from Vesuvius that were burnt from the explosion of Vesuvius. And so you see something like this. If you open it up, it crumbles, so you can't open them, but they were still able to have the computer magically read what's inside. And you have some easier problems with palimpsests where things are scraped and rewritten, famous Archimedes texts like that. So here the problem is to read what's inside without opening it by imaging the interior of the scrolls. And this is perhaps the greatest thing for humanity since the Dead Sea Scrolls. Remains to be seen, because now we can read things, classical texts that are unknown and so on. Not the subject. So moving on to Qumran, that's Isaiah scroll. So they've been, the Israel Antiquities Authority is re-imaging them in high quality, multispectral, from every angle, raking lights and so on. And so one thing you want to do is take these images, and usually the infrared shows you the ink best, and try to extract the letters. So find the lines, find the letters. The images look like the one on the left. Again, we want to separate between the image of the fragment and the background. And here they decided to image everything on a black background, which looks almost identical to ink. So if you try to remove the background, sometimes the computer might make mistakes for various reasons. So this is the mask showing where the fragment should be. So, then the other problem is that you have this paper that the conservators use to preserve them, and you also have to get them out of the way, like here. So we can try to do that. And for the holes, if you have a hole, then you see the black background instead of the blank ink, and that can be a problem. So one solution might be should be running or ran recently is to compare the recto and verso images of the two sides, and holes will be on both sides, while ink should only be on one side, and that way you can remove the holes and reconstruct it. There are also old images taken in the middle of the 20th century in infrared, but here, so you have them on a white background, and sometimes it's nearly indistinguishable, and you have shadows because the fragments aren't flat. And again, this is by the Rockefeller Museum, the Palestine Archaeological Museum, that expert photographs, but still we need to remove to see where the fragments are and where the background is. So sometimes successful, sometimes less successful. Remove the shadow, as I said, and use some kind of network to learn what a shadow, to distinguish in shadow. And then, so now we have old images and the new images, high quality multispectral image on the right, the old infrared image, and they each have advantages because the multispectral high resolution shows you things that you never saw before. But the edges often have disintegrated in the past 50 or more years, and there were things you could read before that you can't read now. And so you want to do what's called registration. Take the best of both images and put them together. The problem is that they've warped over time. And this this registration problem crops up over and over again. We have more than one image of the same thing, and you want to match them up as best as possible, and it's not always easy. Once we have them, once you have all the images, then you want to sort of put them together and read every letter that's possible to read in any of the images. Another thing you want the computer to do is decide whether something's papyrus or leather. And there was just a recent paper from the team in Groningen claiming to be able to do that successfully with the Dead Sea Scrolls. Another thing you want to do is you have all the Dead Sea Scrolls were transcribed, and you want to match each letter, the transcription with each letter of the image. And that's another thing we worked on and with partial success. Another thing which I mentioned before is you have a broken letter. So this is from the Passover papyrus from Elephantini, and there's an argument about what it used to say there. So the letter on the left is broken, and the question is what letter that was. And there have been several projects also with cuneiform to suggest how to fill out, how to make a letter out of the broken letter, and that might be useful too. Getting back to the scripta cumanica, so you have the image, you have the transcription, and the goal was to allow manipulation of the images and the text to be able to, for a scholar to be able to put out an edition, to be able to place things on proposed reconstruction, and so on. And this project will be available to scholars on one of these on the Israel Antiquities Authority site. Okay, so these are Bronson's images. It says someplace, and now once you have these old images I told you of the Dead Sea Scrolls, and you have the new ones. So the computer separated the fragments from the background. And now we want to look in these old images for the fragments that we see in the new ones, and we don't always know where they are. And that's also challenging. So here, this thing on the left, can you find an image on the right? Okay, sometimes the computer finds it, which is nice. And in that way, we've been able to locate lost fragments in the old, that over the years moved from one place to another, and I've been able to find them. But that needs to be done on a wholesale scale with all the images to find all the images of the same fragment. Other things you might want to do, and we haven't done it, is like see damage patterns and how they repeat themselves, isolate the letters, find letters, cluster letters, and so on. And if you can find the shapes of the letters, then you can use it to try to decide the time based on the handwriting when it was written. Let me and then distinguish different hands, different scribes, answer questions about the scrolls. Moving to the Gnizah. This is a famous draft by Maimonides. They were found in a heap like this in in a room in the attic of a synagogue. All kinds of interesting things there, usually in bad condition. So the Friedberg project paid to have them all digitized, and then the computer was given a task with counting lines, taking straight things out of the image, straightening them out, measuring things, identifying more than one fragment, measuring margins, and so on. And these are easy for the computer to do. And the computer can do this for each and every page. And finding regions, here things are written sideways and upside down, and see scribal flourishes of various sorts. Something one might want to do, and we haven't, is to match up wormholes and use that to decide that these two are part of the same book. Or can the computer distinguish in Hebrew and Arabic? Well, this is easy. Sometimes it's not. In general, paleography wants to know when, where, and who things were written by. Was it in North Africa or Spain? Is in square script or semi-cursive or cursive? So several teams have been successful in classifying these images into the major categories. But And we'll get back to that later. The one issue is when you've done this, how do you explain to a scholar why the computer decided that something is the two fragments are written by the same hand or belong in the same category? And you need to show the scholar what's similar and what's different, why it is like something or not like something else. And that's still a challenge, how to explain things to the scholar. The big success of the GNISA project was that the computer was able to find many joins. The find that two fragments, which are cataloged separately, are actually from the same original text. Okay, this can be done for any. Here, someone found a fragment in Australia of a scroll of the dead that was in England in the GNISA. He said, putting these fragments together. And these are things that are important. So the computer found that this page in Geneva is from the same book as this page in Pennsylvania, or this tiny fragment in Manchester is from the same book as that fragment in Cambridge, and so on. And then, this is years ago already, we ran compared all fragments with all fragments, and tried now that when you look at a fragment on the GNISA project website, it can suggest you might be interested in some of these other fragments as well. And this has served scholars well. Word spotting or trying to not read the text, but find images that is another, particularly scribal flourishes, which are distinctive for different scribes, would be interesting as well. Now to the last topic for the medieval books. Here's actually a photograph of a lost page of the Aleppo Codex. So we don't have those pages of the Aleppo Codex. This is the Decalogue. And there is this image of it from some book published in 1910, photographed many years before that, I think. This is one of the old, there's an old copy of Euclid. Anyway, there are many medieval manuscripts. These are, and our Midrash project aims to study Hebrew letter manuscripts before the time of the printing press. And there you see the team. And so we have the images, or the National Library provides the images, and the computer in the basement of the National Library needs to run both OCR, character recognition, and segmentation, find the lines, find the regions, try to read the text, and so on. So Daniel Stockel Ben Ezra and his team in Paris have the system called eScriptorium, which is the best there is for finding regions and transcribing at the moment. But we're working on improving the quality of the text extracted using two main methods. One is large language models, which can predict what words make sense in context, and also comparing to other texts that may exist, it may be parallel texts, and use that to suggest better readings and take into account what kind of errors the OCR engine might make. So, this is the segmentation and the transcription. So, and it's not easy. Here you have a Bible text codex with a lot of marginal Masorah comments in the margins. You need to identify them here. This looks all very nice, but there are two languages. Sentence after sentence is a language in Hebrew, and a sentence in Hebrew followed by a sentence of Targum in Aramaic. And it would be not one of the things that we're working on right now is the computer automatically detect the language, and that can help in correcting the OCR, for example. We've built a database of for testing layout classifications. Here's a printed book, but it has two languages, 3 or 4 fonts. Some places have 2 columns, some places have 1 column. To figure this all out is challenging. Here, how do you know? Well, this is just a list of names. How do you know whether to read it across or to read it in columns? Not trivial. Or in what order do you read these pages? Good question. All right, so there's that's a challenge. The reading order. If you find the fragments, how to arrange the lines, figure out in what order to read the lines. The Sofer Stam project in Haifa, or the team in Haifa, the names you just saw on the is mainly using this intertextuality, finding parallel text and choosing the right model and using language models to correct the text, all aimed at improving the OCR with minimal manual intervention. So a big part of the project is computational paleography, not just deciding whether something is North African square script, but getting a much finer distinction. Is this from Germany or from France, for example? So to be able to say that this sample page here is 15th century Spanish, that's difficult. And that's what we're trying to do at the moment. Although this is from Catalonia in the first half of the 14th century, and what makes it distinctive. So one thing Barat is now working on is training the computer to recognize certain features of the letters that are useful for those distinctions. Whatever. So which way the angle goes, which way, a lot of minor features that to help you distinguish between different regions and different periods of time. And then to put this all together, so you have a preliminary OCR, you look for intertext and use that to correct it. You may look for biblical citations. You may, we want to have intelligent morphological search in the end of these texts, and which show you where the words are in the manuscript images themselves. Okay, so there's a lot of intertextuality. This is from the Sefaria website, where in the Talmud each verse is cited. Put this all together. You'd like to look at a distant viewing of the Hebrew manuscripts as they move in time and place, and how some texts are more fluid than others. And thank you very much for your attention. Okay.
Thank you very much, Nachum. I believe that we have time. We have plenty of time for some questions. If people want to ask away and get deeper into one facet or another, that was a real whirlwind. There was a lot going on there. And
that's just the tip of the iceberg.
Yeah,
there's so much to do, but.
So just raise your hand or mention something in the chat and we'll pick up on any questions that anybody has. Or if nobody has any questions, then maybe I can start off with a few things for you, Nachum. So I am a little bit interested in this papyrus, looking at the fibers and how you might match those up. And I hadn't seen before that you are able to extract the fibers. That's really cool. How would you go about, once you've extracted these fibers, trying to match them up with something else?
That's a fascinating question. So let me tell you. So I think first we use like medical imaging techniques to see the fibers. Okay, you can imagine that, you want to see blood vessels. You want to see, so it's similar to see the fibers on the good images, and so papyrus, just for those who don't know, you have leaves going horizontally, leaves going vertically. They're usually read on the side where the side that's written is the one with, I think, with the leaves horizontal, but not always. And so if you see the fibers, okay, so each fiber continues, on a straight line. And now The problem is that nothing is an identical match because the edges are always frayed in papyrus, fragments. So you see some pattern. Let me go back if I can find it. Okay, so you can see, okay, a fiber ends and another starts, but still overall there's a similarity. So the way the computer was, the way we trained here was to take image of a large papyrus fragment and artificially break it.
Ah, okay.
So to train the computer to learn patterns. Now, when you cut it like here, these are two pieces that almost fit one in the other, so it's easy. And take the patches.
You're not sharing your screen, Nachum. Could you?
I am not sharing my screen anymore. Okay, I'll be happy to. Share screen. Okay, I did. Okay, now
Yes.
Okay, so we take these patches and use it to train the computer. These were created artificially. Okay, so you have from large papyrus texts, and tell the computer that the top red one on the left is close to the top one on the right, and you can put them together. And you can see, and I can see here, that there's a similar pattern. Though some fibers are going down, some are going up, but you can sort of see similar texture. The further the two parts are from each other, the harder it gets. Often this is can be used, or a scholar might use it to disqualify a proposed join. Okay, someone says, I think this piece belongs next to that one, and then you look carefully at the fibers and there's a mismatch. That's more, I mean, in practice that works more often than the opposite of here. These two have very similar fiber patterns. Let's put them together. So people are still working on this, and there's a lot one can try to do, at least to confirm. So you might try to put one next to the other based on other factors. The contents make sense to put next to each other, or the shape makes sense, or the fibers make sense. And to use the, first see that the handwriting is similar, and the spacing, the layout is similar. That's what you look at first. Second, you put all these factors together, can be helpful. So this is still very experimental. This was the master's thesis of Ro'i, and the publication that this publication came out of it. But that was a few years ago. But some people have been looking at it more recently, and at least hope to make progress.
Thank you very much.
If you'd like to pick up the gauntlet, that would be great.
I wish I could. I don't have time. I have a question, and I'll get to you, Barat, in just a second. I see your hand. I got a question on the chat. Not my field of expertise, but can you elaborate on the images, Kishutim, recognition that are not texts in objects such as ketuvah, etc.?
Okay. No, there's not much I can say. So looking for regions, we'll separate regions sometimes. You can see a region that is, an illustration or some other special feature. We are trying each to distinguish regions by the style of the writing, but if it's not written, then the only thing that we've done a little bit is looking for certain flourishes. Look for something that looks the same, like a line filler that's the same, or find the line fillers in a manuscript. That we do know how to do, because you can try to isolate a glob of ink that goes together and look for things that look similar. People, I've spoken to people, for example, about micrography, and you want to trace the text in a complicated figure, which is also an interesting problem. but the bigger questions of looking at illustrations in books or the like is not part of. Well, I can imagine that if you isolate illustration, I mean, that they are also distinctive, and you can use things that people have done about matching art styles to try to match some of these aspects of Ktubot or the like.
Thank you. Barat, do you have a question?
Yes. Thank you, Nachum. When you are talking, I recognize something from my side that, and I want to ask this question as someone who work in the low-level details, like segmenting into text regions and text lines and letters, and trying to find the paleographical features and trying to transcribe the letters. I recognize that I am losing the high-level perspective that you give us in this presentation. So I would like to ask you, what is the most exciting utopic goal of the manuscriptology, do you think?
It's very hard to. The computer can. The point. The question for me is, what can the computer do better or more than a scholar? So a scholar can pore over a single page for a whole day, and either look at paleographic features, or looking at other textual features, or being a philologist and trying to look for parallels any place you can think of. And these take a lot of human talent, but a human can't do that for 100,000 manuscripts. And the computer, it's just a matter of time, and it doesn't. We're getting powerful computers, and they can look. So what I think is the most interesting of those things that take the large scale data into account and take advantage of them. So you can trace, for example, how does the text change over time? So you want to find parallels to the same expression, but see how does the orthography change? How do the way things are expressed change? Or searching. So a scholar came to me once and said, why can't I look for these 3 adjectives appearing in a row, and I don't care about the, whether it's what gender it is or what number it is, but do you have this sequence of adjectives? So he's a genius. So he remembered, something here and something there, but the computer can search everywhere. And his examples was one from Qumran and the next one from the 15th century Spain, and maybe there's someone in between, but who's going to find it? So those are the kinds of questions that the computer is better, more adept at. Other things, I mean, some of the things we're talking about, which have to do with vision, vision, seeing, multispectral, these are things that also require computers. But that's what I would look for, things that, okay, so we're talking to paleographers. So they have trained their minds to see things that normal mortals might not notice. But again, they can't look at everything. So the computer can find exceptions, outliers, things that are different, things that don't fit the known patterns, and then challenge the scholar to explain them. That's the kind of thing that I'd like to see.
Thank you. Sorry. When you were answering me, it come to my mind something extreme, so I would like to learn also your opinion. So currently, to achieve the goals that you mean, we are trying to transcribe most. This is the most basic, I think, most basic thing we have to do to reach to the goal that you mean. In the letter level, we need to transcribe in the letter level. So we have, but the input is images, but we are trying to transcribe this into computer readable text. But as I know, for example, in large language models, also in the beginning, they were trying like such, for example, in translating from one language to other, word to word, and so on. Those methods did not work, but recently other perspectives were better than the previous perspectives. Do you think such thing can be valid for document image analysis? I mean, instead of trying to transcribe letter by letter, maybe the input images itself can be the source of the reaching information. But maybe it's very extreme thinking.
I think you're right. But first of all, what you said about transcribing, that's mainly important for the medieval manuscripts, 100,000 Hebrew manuscripts. It's not, I mean, all the Qumran material and much of the Gniza has been transcribed by hand. And so we have the transcriptions. And so then there's still many interesting issues, but that's not it. But what you're saying, I think that's definitely the case. To take, for example, if you're looking at a text, I mean, a scribe may have a few ways of writing the same letter, aleph, allographs that may look a little bit different, but there's a similarity in the way that scribe writes an aleph throughout the manuscript. And for the engine to take that into, for the OCR transcription to take into account, not in the way it does now, which is just train a model and then use it every place, but to take a more holistic look at the manuscript and then realize what an aleph in this manuscript looks like might be useful, for example.
Thank you.
I'd like to get a question in. I have Ofra and then Daria, and hopefully we have time for both. So Ofra, could you let us know what you're wondering? Or is Ofra gone now? Yeah,
I don't see her.
Seems to be gone. So then Daria, you're up, and if Ofra comes back, she'll get a chance.
Okay, excellent. No, I just wanted to say a very small thing. Looking at this last picture, I think maybe we should use more codicology. It's right that the computer cannot physically extract codicological features, but for example, for cataloging of poorly accessible and poorly cataloged collections, extracting codicological features is often done even in the poor catalogs, and even not trained, like a local specialist not trained for Hebrew or for any other Jewish language can still extract them. And maybe we could it's not that exciting from computer science's point of view, but it can maybe refine our results in paleography. But what do you think, Nachum?
Definitely. I mean, Daniel Stockel Ben-Ezra just told me yesterday or the day before that his algorithm decided that something that was cataloged as Hebrew is really Judeo-Arabic or something, with simple methods. And again, so that is a good example. All this catalog information, or redoing it by computer, and then someone can look at discrepancies. And also that the computer can look at every page. When the librarian catalogs something, they look at 2 or 3 pages. They don't look at 200 or 300 pages. And all this kind of work can be done page by page, for whatever it's worth. Definitely.
As long as you can encode it in a meaningful way that the computer can understand. I have also, I think, probably our last question from Ofra. Hopefully her connection stays stable long enough. We're ready for you now, Ofra.
Maybe I can try. Can you hear me?
Yes.
I was disconnected for a large chunk of this, so I may be just repeating things asking you to repeat things you've shown, but I'm interested in mixed texts such as Hebrew and numerals or numbers, mixed languages. think I saw on your site something about directions. So the commentaries come in different directions, and but I'm interested in whether there are examples or any brilliant ideas in progress on managing these multi-directional material.
Yeah, that is something that we're actively thinking about, indeed. So we're trying both on the regions and lines and words, and to first. So things we're looking at. Often the style is different of if you have interleaved languages, like you can have strictures to a work that appearing in the middle of a text where a gloss of some sort, and it'd be written in a different hand or printed in a different font. Yeah, we're trying another problem that's very much that we've worked actively on is a text like Judeo-Arabic, in which you have interspersed, if it's a Bible commentary or something. So yeah, it's interspersed with all kinds of Hebrew words. And that's one thing when they're separate words, but also you have things like al Shechina, the Shechina, because Shechina isn't translated into Arabic. And so this is something called code switching, which is something that we've tried to train the computer to decide the language of each word somewhat in context, and also to split words, at least with common prefixes, and decide whether it is an Arabic prefix with a Hebrew word, or an Arabic word, or a Hebrew word. So these are all actively researched questions, and I'd love to think with you more about such things.
The examples. Is there, maybe, looks like I have a great connection, so I can just go on out. Not being, so does the distinction between types and tokens play any role in the work?
Well, certainly frequencies of things play a big role, and so yes,
Yes.
I'm
sort of, I mean, one question I could formulate is whether how ambitious one is in trying to identify or to distinct how far to go in identifying types of letters in different handwritings. Anyway,
yeah, for sure. Yeah.
I'm sorry, I kind of need to interject. I don't know how strict we are on time, but we're a minute over. And so I will leave it to Vera to decide if she needs to cut this off now, or if we get to hear just a little bit more wisdom and information from you, Nachum.
I'm no longer.
I didn't hear you.
So Daria will decide.
I can just write to you and
And I'd love to talk to you at length about Judeo-Arabic things in general and so on. So yeah.
And if you can crack that problem, I think you can make money on this one. This is a big problem overall in the world of how do you tune a computer to read a newspaper? Not very easy, and our stuff is harder than that. I want to thank you very much, Nachum, for presenting all this today, and I thank all the people who took part for their lovely questions. And I was happy to be able to join in and learn something myself. So I hope you have a lovely rest of the conference. Thank you all.
Thank you.
Thank you very much. Thank you, Nachum. Thank you, Bronson. Thank you all. And we'll meet in 1 month. There will be an announcement. The next lecture is by Jad El-Sana.
Great. Thank you, everyone.
Bye. Goodbye.
Good day.
See you next week, Nachum.
Peace and quiet.